Factoring special cases. After watching this video, I will be able to apply the special case formulas to factor a quadratic expression. So first, let's remember what happens when we multiply two binomials that look exactly the same, but the signs are different. So we would get b squared, then we would have a negative 4b and a positive 4b, and then 4 times negative 4 gives me negative 16. When we combine like terms, that cancels out because negative 4 plus 4 is 0. So we are just left with the square of the first term because b squared is b squared. And then we end up with the square of the other term because 4 squared is 16. And because of the positive and negative, it gives me a negative 16. So there is a pattern that is developed, and we could use this to easily factor something that looks like this. So all you need to know is your perfect squares by memory to make this process very simple. Here is a list of the first perfect squares from 1 through 20. That should say 20 for you. So basically, whenever you are given something that looks like a number squared minus another number squared, the factors will always look like this. So determine if your two numbers are squared. So n squared, that is this perfect square. 25 is a squared number. So my factored form is basically I'm going to split up the first term because it's being squared. And then what is the square root of 25? Well, 5 squared gives me 25. So I'm going to do plus 5 minus 5, and I have factored using the formula. So again, let's see what happens down here. Is 16 a square? Yes, it is. Is x squared a squared? Yes, because of the little 2. Is 9 a square? Yes, it is. So I can use this formula. So I'm going to put my two parentheses. I'm going to have a plus and I'm going to have a minus. So what is the square root of 16? Well, that's 4 squared, so 4. Because I have a k squared, I'm going to split that up into two different k's. And now what gives me 9 when squared? Well, 3. So 3, 3. We have another rule that we can use called the perfect square trinomial. So let's recall what happens when we have x to the 5 squared. So x to the 5 squared means x times itself. So when we multiply this out, we end up with x squared. We end up with minus 5x. Then we end up with minus 5x again. And then we have to do 5 times 5, which is a positive 25. And when you combine like terms, that gives me negative 10x. So another pattern is developed here because if I'm trying to factor it out, notice that 25 is a perfect square. 5 times itself would give me 25. And if I were to multiply 5 times 2, I would get the 10. So let's look at the formula. You must first determine if you could use this formula. Is the first term a perfect square? Yes, 16 is a square. X squared is a squared. Is the last term a perfect square? Yes, 9 is a square. The middle term, it's a little confusing when you first think about it. Is it the middle term twice? So we are multiplying by 2. The product of the square roots. So first, what is the square root of 16? 4. What is the square root of 9? 3. So when I multiply 4 times 3, I get 12. And then I multiply that by 2. I get 24. So because I said yes to all 3 of those questions, I could use the formula. Because They are both positive. I am using this first one. So I am taking the square root of the first term, which is 4. Square root of the x squared, which is x. I am using a plus. And then I am doing the square root of 9, which is 3. And all that squared will take me to this problem. So let's process this again. There are two different formulas, and the only thing that is different is the sign. So I first need to determine which one am I going to use. Because I have a minus, I am going to use this one. Then I must determine if they're all, the first term and the second term are squared. So what is the square root of 4? Well, 2 times 2 gives me 4, so that is a perfect square. X squared, so that is a perfect square. 25, square root of 25 is 5. So that is a square. We're good. Then I need to take 2 times the A times the B. So 2 times 2 is 4. 4 times 5 is 20. So yes, I could use the formula because it is a perfect square trinomial. So now what is my A? My A is just 2 because that squared gives me the 4. And then we have an X. I'm going to use a minus this time. What is my B? 5. And that to the power of 2. So if I am factoring this, I could just use the formula. So now, up to now, we've had a lot of different ways of factoring different expressions. So we could use this flowchart to kind of help us determine how to factor depending on what information we are given. So the very, very first step is to try and find a GCF if possible. It will not always be possible, but you should try and do that first. And this was lesson 58. Then based on that, you want to determine how many terms you have left. If you only have 4 terms, the only method you can use is grouping, which was lesson 59. If you only have 2 terms left, then you are just basically going to use the difference of squares formula, verify that they are both squares, and apply the formula. There are instances when something is unfactorable, but up till now, that will not happen. But when there are 3 terms, there are actually different methods we can use. So if there are 3 terms, the most common method is the reverse FOIL or the product sum, which was the previous lesson, lesson 60. Then, the perfect square trinomial, if it meets the conditions of being a perfect square trinomial, you would apply the formula. There will be instances when none of these previous methods will work. The next lesson will show us the remaining way that we can factor something using something basically called the magic X. You should definitely keep this flowchart near you when trying to do the problems to be reminded which method to use when.